Now let's take a look at these properties. This says, suppose that the power series, Cn x minus a, converges on an interval here to here. For some r greater than 0, let f be the function defined by the series. So now what it's getting at here, when I look below here, it's saying, hey, I can think about the derivative. And I can take the derivative of a series. And that's what this is here, because notice the original here, it says Cn to the x minus a to the n. And if I take the derivative of this, I bring the power down, and I lower it by 1. So I can do this with series, which is really cool. And then I can also integrate. I can also integrate too. So then when I integrate this, notice this, I raise my power by 1, and I divide by the n plus 1. So I can do both of these. So this is actually really nice. So now we have derivative and integral. So let's get started. So let's take a look at this problem here. This is nice. So when I look at this problem, now that I have these other tools, I don't have to worry about addition, subtraction. I can talk about integrating or differentiating. So if I know the ln, and if I take the derivative of the ln, I know that the ln of 1 minus x, when I take the derivative, is going to be 1 over 1 minus x, and then times the derivative of the inside, which is going to give me negative 1 because of a chain rule. So it's going to be negative 1 over 1 minus x, which is actually close to the representation of the series x to the n. But I'm going to pull the 1 out. Now I get exactly that. So I can say that the derivative of my function that I have to begin with is actually equal to the negative series from 0 to infinity of x to the n, which is pretty cool. But now that tells me if I know this series here is equal to the derivative of my function, then that tells me if I take my series n equals 0 to infinity of xn, and I integrate it, then that should be the series that equals my function, my original function. So now this equals the negative, series n equals 0 to infinity of the integral of x to the n. So the integral of this, x to the n dx, is going to be negative the integral n equals 0 to infinity of n plus 1 on the bottom, x to the n plus 1. So there it is. So that's going to be my series for my ln of 1 minus x. Hopefully you guys follow that okay. So then my final answer, I'll just rewrite it for you. Is this right here. Done.